For the number 2, an ideal Otto cycle engine with 15% clearance operates on 0.227 kg mass per seconds of air. Intake state is 100.58 kPa, 37.7 degrees Celsius. The energy released during combustion is 110 kJ per second for hot air standard with K to 12.32. Compute P1, V1, and T at each corner for the B, VNet, and for the C, E, and D, and PM. So, yung mga given is C equal to 15% or 0.15, and for the M equal to 0.227 kg mass per seconds, and P1 equal to 100.58 kPa, and T1 37.7 degrees Celsius, and QA 110 kJ per seconds, and K equal to 1.32. So, yung pinapahanap nila dito is P2, V1, V2, T2, P3, T3, V3, P4, T4, V4, VNet, E, and PM. So, dito na tayo sa solution. For the solution, una nating isosolve ay ang P1, B1, T each corner. For the B1, the formula for the B1 is MRT1 over P1, and B1 MRT1 P1, and for the B1 0.227 kg mass per seconds multiplied by 0.287 kJ per kilogram K, and 310.7 kilo over 100.58 kPa. The answer for the B1 is 0.201 cubic meter per seconds. For the B2 equal to V1 over RK, and V2 equal to 0.201 cubic meter per seconds over the RK, or 7.667, and the final answer for the V2 is equal to 0.026 cubic meter per seconds. And we solve for the RK. For the RK, for the formula is 1 plus C over C, or 1 plus 0.15 over 0.15. The final answer for the RK is 7.667. Next is for the T2. For the T2, formulang gagamitin natin is the 1 to 2 is equal to C, and ito yung T2 over T1 equal to B1 over B2 K minus raised to K minus 1. The formula for the T2 is T1 RK raised to K minus 1, or 310.7 K multiplied by 7.667 raised to 1.32 minus 1. The final answer is the 596.240 K. For the P2, formula na gagamitin natin is 1 to 2 S equal to C, or ito yung P1 B1 raised to K over P2 raised to K equal to P2 B2 over raised to K over B2 raised to K. P2 or P2 equal to P1 RK raised to K. Ito yung 100.58 kPa multiply by 7.667 raised to 1.32. Ang nakuha nating answer for the P2 is 1,479.848 kPa. For the T3, the formula for the T3 is T2 minus T3 B equal to C, or ito yung QA equal to MCB T3 minus T2. And yung pinaka formula na gagamitin natin is T3 equal to QA over MCB plus T2. QA is equivalent to 110 kJ per seconds over 0.227 kg over per seconds multiply by 0.897 kJ over kilogram kilo plus 596.240 K. And the final answer na masasolve natin dito is for the T3 is 1,136.465 K. Next is for the P3. Gagamitin natin is 2 minus 3 and B equal to C. The formula for the P3 is P2 T3 over T2, or P3 equal to 1,136.465 K multiplied by 1,479.848 kPa over 596.240 K. For the P3, the final answer is 2,820.669 kPa. For the B3 naman, based on PV diagram, B3 is equal to 0.026 cubic meter per seconds. And for the P4, gagamitin is S equal to C, or ito yung T4 over T3 equal to P4 over P3 raised to K minus 1 over K, or equal to B3 over B4 raised to K minus 1. Ang ginamit na formula is P4 equal to P3 over RK raised to K, or the P4 or the P3 equivalent to 2,820.669 kPa over 7.667 raised to 1.32, and makukuha natin final answer is 191.712 kPa for the P4. Next na isosolve natin is for the P4. The process 4 minus 4 to 1 and B equal to C ang gagamitin natin, which is the P4 B4 over T4 equal to P1 B1 over T1, T4 equal to P4 T1 over P1 P1, which is 191.712 kPa multiplied by 310.7 K over 100.58 kPa, and makukuha natin answer is 592.214 K. For the B4, based on PV diagram, B4 equal to B1, so B4 is 0.201 cubic meter per seconds, and solve for Vnet. The formula for Vnet is equal to QA minus QR, so wala pa tayong QR. The formula for QR is MCB equal to T1 minus T4, or 0.227 milligram per seconds multiplied by 0.897 kilojoule over kilogram A multiplied by 310.7 minus 592.214. The final answer for the QR is negative 57.328, or 52.652 kilojoule per seconds rather. And for the VNet, the formula for VNet is for the E. The formula for the E is 1 minus 1 over RK raised to K minus 1, or 1 minus 1 over 7.667 raised to 1.32 minus 1. At para makuha natin yung percentage nito, multiply by 100. So the final answer for the E is 47.890%. And lastly, for the MP, the formula for the MP is equal to VNet over VD, or VNet over V1 minus V2. For the MP, 52.672 kilojoule per seconds over 0.201 minus 0.026 cubic meter per seconds. And the final answer na makuha natin for MP is 300.983 kPa.